Hi, my name is Gary Taylor, and in this video we're going to get an introduction to Dapr. This is going to be another training course that I do where I'm just going to be playing about with the software just to try and work out what it is, what problems does it solve, and how can we implement this and use it within our system, should we? So this first video is going to be more of an introduction to discuss what actually Dapr is, and I like to think about what is the problems that this particular system is designed to solve. Now, I think first and foremost that if you are using some orchestration, some architecture, like microservices, distributed systems, message transfers, any kind of distributed system where you are building individual applications and you're deploying them, then you're going to run into a few problems. Now, this is not going to be a microservice talk. That would be a whole section of its own right, and therefore it's important to know that the problems that this is designed to solve are the problems that you get when you start having a distributed system. So let's head over to Google, shall we, and put in distributed system. Note that I'm not putting in microservice yet, just distributed systems. And just get a sense of the pictures and the commonality between the pictures. We can see that we're talking about systems that can intercommunicate with each other. There isn't a central orchestration or some central server that's responsible for everything. There is really this distributed mesh of systems intercommunicating with each other. Now, the problem with a system like that is that what about resilience, scalability? What about the ability to recover or to release new features and do A/B testing? Does every one of these systems now, being typically an API, need to be behind load balancers, some kind of discovery that says, right, there is a new system on the network now, therefore it needs to become available? What keeps track of that? So let's look at a really simple system here. We have 3 web servers that are connected, and there is a choreography between them. In other words, these services can talk to each other, these services can talk to each other, and these services can talk to each other. And they do this in this round fashion. Now let's say, for instance, that we want to deploy a new version of this web service. So we take it off and we put a new one on. Now, unless we keep the same domain name and we keep the same IP address or things like that, then these services are going to lose connection. Unless we're able to hop swap this service on the fly and turn one off and put the other one on within milliseconds, then we're going to lose some kind of connectivity. But also, if any one of these services starts to get a hyperload or CPU or memory problem, then they're going to start to fail. So as we get bigger, we need to scale outwards and we need to create multiple instances of this system. So we now need some kind of coordinator that can tell us how to access multiple instances of this. Otherwise, we have to write that into every one of our applications. And that kind of service discovery becomes incredibly complicated when you then have a system like this, where every system is intercommunicating. Now, a very common solution, and a good solution in my opinion, is to choreograph the communication between these services so that we don't have a lot of REST APIs all calling each other. We have a typical event system, some kind of middleman that delegates responsibility. And we can loosely couple how these systems intercommunicate with each other. Bear in mind that this type of communication is still existing, it's just we're going through a central hub. And these can be things like Kafka or RabbitMQ or many other event systems. But the idea is that these raise an event, they subscribe to this event system, and that gets delegated to the appropriate system. and including really complex patterns like making sure that 3 systems get notified about that one event. Instead of this system making 3 calls, or say for instance this one making, well, I'll go with 3, so this one making 3 calls out to 3 central systems, this system just makes out 1 call, and the event hub then translates it back to the 3 systems. Now, this isn't a talk about microservices or even microservice architecture, but it's important to know that Dapr is designed to solve some of these problems. Now, we say that this event system has been solved, we now have this central orchestration, so we don't have intercommunication. In fact, all of these services just connect somehow on some cloud infrastructure and connect to a central load balanced hub, and now that ability for service discovery is built in, and you're absolutely right. But each one of these systems has some code in it, has some config, has some bootstrap boilerplate code, which is designed to allow it to connect to this event system. And over time, the team gets better as they build new services, they improve that underlying code. And the problem is that by the time they get back to the original first microservice that they ever built, or service that they built, that is now hideously out of date compared to the greatness that they've implemented with adaptation over time. Now, any development team will build, measure, learn and adapt. They will look at their code and go, we could make improvements. And with the next service, they get stronger and stronger and stronger, until eventually the very first and the very latest service is light and day because of the learning that they've done. So at some point, realistically, we have to start going back and re-implementing that code base and refactoring and cleaning it up to our best known patterns. However, that is great with just a handful of services, and there's an argument that if you've only got a handful of services, you shouldn't even be implementing distributed systems anyway. So at that point, being able to update and maintain all of these systems just to keep the boilerplate code in check is complex, or at best, time consuming. So, as developers realize this, a common approach is to create a shared library. We have systems in place. A function is a shared piece of code. You write it once and you call it from many different places. So naturally, developers are intuitively led to this shared library state. So you may have multiple or hundreds or even thousands of microservices all sharing this same library, which is implemented using NuGet or whatever that you want to do to distribute that shared library across services. In some cases, this shared library is just a folder which is then recompiled so it gets the latest version every single time it's rebuilt. The problem is that a mistake or a problem within this shared library affects every single microservice. And also, every microservice has to be rebuilt either with the NuGet package or with the direct reference to that library in order to get access to that latest system. Now, over time, this shared library unfortunately turns into a dumping ground for everything that you might consider shared. And developers quickly fall into the trap of, instead of writing code within the microservice, they write code in the shared library and then they expose it to all the microservices. And before you know it, you have a microservice distributed monolith. Now, no developer does this on purpose. Every developer wants to make good, clean, great code. But when you have deadlines and when you have a system that needs to be out tomorrow, or the business is going to fail in some way and it's all your fault as a developer, and the common problems that we face in this world, then we're forced to make these shortcuts. If there is a shortcut available, typically human beings will take it when under pressure. And a shared library is a shortcut. It is a way to implement quick and dirty code to couple systems together to get access, instead of relying on an architecture that enforces a particular pattern and means that developers have to work in a certain way. One of the great benefits of a monolithic application is that ability to just create and access whatever code you want at whatever time, and to make as many changes across the system as you want within your code base without having to speak to anyone. Within a microservice architecture, these services could be built, and generally are typically built, by completely separate teams. So making a change to that in order to satisfy that may require 2, 3, or even 4 sprints before that work is available to you. In a monolithic application, you just simply change the code and you're done within minutes. Within this system, it could take months. The next problem, and there are many and I'm not going to go into all of them, is the sheer complexity of cloud development. Now, cloud development is supposed to make life easier for ourselves, but there's nothing more easier than a monolith where you can just press F12 or F10 and skip through the code until you get to the line that's causing the problem. Or you can just slap on a new couple of classes and a new interface and solve a problem. The problem with monoliths is that they don't scale very well. Allowing multiple developers to work simultaneously can be complex, so we go to cloud. And if the system that you're building is a website anyway, then it feels natural and intuitive to go to cloud development. But within cloud, there are so many services and features that developers can spend more time learning the infrastructure than they do writing and solving business problems. Now, every developer really should focus, along with their product owner if you have one, hopefully you do, that we are delivering value to a business that is going to allow the business to be more optimized, more streamlined, take away any kind of process that's taking too long to optimize it. That is the goal of software development, to provide a service of value. There is no value in the world's prettiest code or something that's considered the best pattern if no one uses that software and that software has no business value or no world value. But in order for developers to get started, they first have to learn a programming language. They have to learn how to work with a team. They have to learn how to deal with systems like Scrum and Jira and Git, and work out how to make APIs, and then work out how to make services and use a system like mass transit. And then each one of these systems that we can see here, a developer may need to understand and learn. And this diagram is only just scratching the surface of the complexity and the features available within any cloud infrastructure. This is probably 5% of what is actually on Azure, and the other services are just the same. The other cloud providers. Now, I'm not saying that Azure is better. In fact, I'm not. They're just showing this as an example. So the learning curve now for a developer to be able to get on board, a 2-year developer, bit of experience under the belt, just trying to get into microservice or cloud development, has typically worked on a project that's an intranet or an internal system, which is some kind of MVC app or basic standalone application, and now they're wanting to go into a distributed system because they've heard that's where the cool kids are. The learning curve for this is tremendous, and in order for businesses to get value out of developers, we have to train people up on the appropriate stack that the development team have chosen, or we hope to God that they somehow magically learn as they write great code. And for a business, neither is good, and for the developer, neither of them options are great. So I think it's clear that when you go to a distributed system, you swap your problems. You go from a monolithic application to microservice or distributed or event-driven systems, and you're really swapping a set of problems for another set of problems. And it means that now you can scale, you can build up your development team, you can get bigger, you can hopefully build systems and solutions quicker, but you've also inherited a lot of complex distributed problems. And Dapr, these problems, they already have known solutions to. There are already existing implementations and systems out there to solve every one of these problems. But the problem is that developers have to learn them, and they have to be trained, and we have to play about and discover and work with every one of them systems that is designed to solve a problem. Service discovery. There is at least 5 great solutions to service discovery. So first off, the team has to review them and then pick one and then implement them and then train every new developer up on the service discovery pattern that they use. So every new person who comes in who's not used that type of service discovery now needs time to learn it and maybe make a few mistakes and deploy a few systems that don't register themselves correctly or don't have traceability because they've not implemented a certain line of code that configures them. This implements real friction for getting new products and new features out of the door and being used by the business. Now, like I say, all of these problems have been solved, but in doing so in quite a complex way. So Dapr is designed to simplify how them problems can be solved using a common approach. And a belief was and is that developers understand how to use a native SDK, a library like a NuGet package, and developers know how to make a HTTP client. And if they don't, learning them things is vital for every developer's progress, but also very, very easy to learn. You can definitely learn how to use a HTTP client within a week. The next thing is that Dapr loosely couples the implementation of these solutions. How do you do service discovery? How do you connect to a Redis cache? How do you connect to SQL Server? How do you connect to other infrastructure? How do you send an email? All these problems that we get as developers that should be crazily simple require weeks worth of knowledge of a particular application, service or infrastructure. So Dapr loosely couples that by providing a simplified HTTP client interface. So a great way of looking at this is Dapr provides another layer of abstraction. We could, if we wanted to, write an API in binary. And it's quite possible to do, to write all the binary code that sends the instructions to the CPU that fires up a web server and makes an API. But it would probably take a couple of lifetimes to do. So you could write it in assembly and would probably take a lifetime to do. Or we could write it in C and take a couple of months. We could write it in intermediate language in maybe a month. We could write it in C# and probably take a couple of days. Or we could download a NuGet package and we'd have to learn that package and that service, and it would probably take a couple of days, but then after that would take a couple of minutes once you understand the package. So this is just yet another layer of abstraction. If you want to send an email, if you already know how to make a HTTP request, you can now send an email. You just need to know the URL. If you want to get some information from a cache, and you know as a developer, I want to record something in a cache, I don't care what cache, I don't care where the cache is, I just want to record a value for this session, then you make a HTTP request to the caching endpoint and you get cached data back, or you get to save your cached data. You don't care as a developer how that's happening. You don't care how the binary is actually working on the CPU and how the transistors are actually flipping in the CPU. That's way beyond what you need to know in order to make a button on a website. We are starting to use so much layer of abstraction that we are now able to develop systems quickly, and understanding how these things work under the hood, although as an old guy I believe that's really great to know, it's not vital to know in order to get business value out to the business. So common questions that I've asked of teams and other developers is as follows. And I did this years ago with React. You know, we looked at React and we asked a couple of questions, and people said, "Oh, well, isn't this not really ugly? You're stripping and putting together your models and your views and your presenters layers all together as one. You know, your MVP patterns and your MVVMs, and they're being squished into just one file. And I thought we were better than this. And look how you've mixed HTML in with your code. Oh, that's disgusting. That reminds me of PHP back in the day." And actually, once you start looking at React and you get over that false negative impression, you realize that actually having a separate view for your testimonials is silly, because where are you going to put your testimonials? You're going to put your testimonials on the page for your testimonials. You're not going to try and mix your products or your data about a third system into testimonials. You're going to put testimonials into your testimonials data. You're then going to put that data into your testimonials page. So the whole idea of an MVC or some kind of pattern that separates these three things actually ended up being pointless once you really thought about it. And I want to make sure we did the same thing with Dapr. There are some conceptions that you might get when you first look at Dapr and say, well, can I do all this in some common library and I can just import it into NuGet? And the answer is, of course you can. You could write your own common component, and then you could create an interface or create some kind of extension methods that allow you to decorate your code. But the problem that you'll get with this is that in order to deploy the latest version of your common library, you'll need to recompile every one of your microservices and push them out. A common library typically ends up being complex, with things like extension methods that throw exceptions deep down into the guts. That means that when you get a stack exception, it doesn't actually tell you where the problem is. You know, problem in startup or problem in program. It's like, great, thanks very much. That doesn't tell me anything. The next thing with the common library is that they end up being a dumping ground for lots of ideas and boilerplate code that developers want to share, and they don't become a helper of services. Like, here is a email, here is Redis cache, this is how we connect them easily and consistently across all of our services. They end up implementing business features, business logic and business rules inside a common shared library, and that is deadly, because basically you've created a monolithic microservice or monolithic distributed system. And although in some cases they do solve a particular problem, I wouldn't say that that's an architecture that you're striving for. Another one is, well, if we're sending an email and I'm going to send an email using something like SendGrid, well, I'm going to have to make an API call to SendGrid. So why would I make an API call to Dapr for Dapr to then make an API call to SendGrid? That's a great point. That is a great point, in that you're making a call to another call and you're putting something in the middle of your infrastructure and your business logic. And why would you do that? There needs to be a reason. Now, of course, the most simplest answer to that is that if you chose to use a different email system other than SendGrid, you can quickly adapt Dapr and change it to send it to another system. But I always find that answer a bit of a cop-out, because businesses don't just quickly change their email overnight. They don't decide one day to use SendGrid and then another to use MailChimp or whatever. They generally stick with a particular solution for quite a long time. So that ability to just quickly flip doesn't feel quite right to me, although it is something that's good. It means you're not tightly coupled to a particular implementation. But for me, one of the strengths is that the API and the implementation to send an email using Dapr is remarkably simple. There is one central place and there is a common theme a common pattern, a common ecosystem to the way that Dapr works. All the endpoints that you call, all these HTTP endpoints look and feel and smell the same. Where there's a huge difference between how you would send an email with Force24 or SendGrid or MailChimp or even Microsoft's notification system or AWS. You have to learn the nitty-gritty, the inner guts of these systems and how you to put that payload together in order to send it. You need to be bothered with keys and security and IP addresses and things like that. That's not really something that you want to get involved with as a developer. After all, you was tasked with sending an email. Something that was one or two lines of code in your monolithic application, hook up into Outlook and send an email. It's all the days were simple. But now you've got all this infrastructure and problems. What happens when SendGrid's down? What happens when we make a call and it fails? Does that email get lost? Or do we need to cache it? Do we need to do resend policies? Do I need to have to keep retrying until the email's gone? At what point do I tell the notifier, the person who sent it, that sorry, I was unable to send this email? And what does that look like? How does that find its way back? Does it need to be acknowledged? Does it need to be resent? Does anyone in the business, like compliance, need to be told? If this was an email that was going out about maybe terms and conditions of a particular FCA product, then that email needs to go because that is a legal requirement. Now, sending an email just all of a sudden started to get quite complex. With Dapr, you call the endpoint to send an email and you forget about it. It's going to get sent. It's going to retry. It's going to try. It's going to have all the configuration that somebody else or maybe a DevOps team or maybe even you has configured once and said, this is how I send an email. So it turns out that Dapr starts feeling like the jQuery for microservices or jQuery for distributed services, and that's not a good thing. Well, I think that's wrong on 2 points. One is that jQuery was tremendously successful in allowing people to build more complicated and better user experiences for customers. It abstracted away the complexity of JavaScript. It abstracted the way of dealing with different systems, aka different browsers. So you could think of this as the complexity of having to deal with different caching systems, different ecosystems, different cloud providers. It abstracts the complexity out. So you teach your developers Dapr, you teach them how to make one API call using Dapr, and instantly they know how to use all of the features provided by Dapr because they have a common, consistent theme. It is a jQuery of distributed systems. So for me, that is a good thing. Finally, there may be complex requirements that you have in your business. Dapr doesn't support everything. So if you have a arbitrary system like, let's say, Memcached, and there is no provider for Memcached, it's maybe not in their list of provided solutions, then unfortunately you can't use Dapr. That's not true. You are able to, because this is open source, this is open community, and it's a plugin based system, you are able to build your own library that will connect to Memcached, and as long as you implement the same API calls and implement it into the module, then you can actually include your own services directly into the Dapr system. And other developers are doing that daily, where they're providing plugins that allow you to extend Dapr to give it more than the common set of 5 or 6 things that it does out of the box. Now, it is true that even with the things that Dapr does support, like for instance RabbitMQ, that there may be some deep mechanics under the hood, like configuring quorums to only connect to 3 out of your 20 clusters or something really arbitrary like that. It's possible that them things can't be configured within the Dapr system yet. And in that scenario, then you're right, you might have to build your own plugin, you might have to build your own system into Dapr, but it's not the end of the world, and Dapr is getting bigger and better every day as the community helps to extend it. Now, what I would say that if you do have these deep requirements, then maybe the solution is to solve that deep requirement, because you have got a business only problem there. If you are doing something that unique, you can't expect a developer to come on board and start working with your system and just instantly know them your business quirks. Try and get rid of them things. So that was a semi-quick, still 30 minutes, sorry I know I had to talk, a semi-quick introduction to Dapr. Within the next videos, we're going to start going through the documentation one by one and just having a bit of a play and seeing what it does and how it works. So join me, and as always, if you like it, please give me a thumbs up. It does help with that algorithm.